My dear students, in this video I am going to introduce a double factorial. In our previous video I have defined what is factorial of n natural numbers. Factorial n I have defined in the previous video, that is single factorial. Factorial n, from our previous video we defined that factorial n is equal to 1 if n is equal to 0. If n is equal to 0, you get 0 factorial, which is 1, you know. And if n is not equal to 0, in this case n factorial is n into n minus 1 into n minus 2, etc. 3, 2, 1. This is n is not equal to 0 case. If n equal to 0, this is 0 factorial, you get 1. If n is not equal to 0, n factorial is n into n minus 1, n minus 2, etc. 3, 2, 1, you know. Now this we have seen in our previous video. Here I am going to define double factorial of n. Double factorial of n natural number. Double factorial of the natural number n is defined by n factorial. Double factorial is defined by n double factorial. That is, n double factorial is, in this case also you get 1 if n is equal to 0. If n is even, n into n minus 2 into n minus 4 into n minus 6, etc. 4 into 2. Final number is 2, last number. If n is an even number. If n is odd, you get n into n minus 2 into n minus 4 into etc. 3, 1. If n is odd number. This is double factorial of n. Double factorial of n can be defined by 3 cases. If n is equal to 0, double factorial of n is 1. If n is even, double factorial is n into n minus 2. You have to reduce 2 to terms up to 4 into 2 if n is even. The same procedure is adopted if n is odd. It should be ends with 3 and 1. For example, n is even. 8 double factorial is equal to 8 into 8 minus 2, 6 into 6 minus 2, 4. 4 minus 2, 2. That's all. This is 8 double factorial. If n is even. Suppose if n is odd number, 9 into 9 minus 2, 7 into 7 minus 2, 5 into 5 minus 2, 3. 3 minus 2, 1. Even like that. This is the method of defining double factorial if n is even and if n is odd. Like that, a natural number n a double factorial of the natural number n is defined for even cases and odd cases separately. And also you can find one note, n factorial of factorial, n factorial of factorial. N factorial is not equal to n double factorial. See, n double factorial is difference between, is not equal to n factorial of factorial. n double factorial is not equal to n factorial factorial. For example, see 6 double factorial. 6 factorial to factorial is, 6 factorial is, you know, 6 into 5, 30, 120. 6 factorial is 6 into 5 into 4 into 3 into 2 into 1, 30, 720. 720 factorial. That means one up to 720, 719, 718, etc. up to 1. It's a very big number you get. So 6 factorial is 720 factorial, 720 factorial, you know, 720 into 719 into 718 and so on. Whereas 6 double factorial is by 6 n is even, therefore 6 into 6 minus 2, 4 into 2, that's all. 48 only. See, 6 double factorial is 48, whereas 6 factorial is 720 factorial. Hence, 6 factorial is not equal to 6 double factorial. This is the case. The n factorial of factorial is not equal to n double factorial. Okay, this is the idea about double factorial, and now I am going to move with a new concept, permutation. Now I am going to start permutations. Okay. My dear students, now I am going to study a new concept, permutations. That means permutations of distinct objects. Permutation means ordering or arranging or listing the different objects. Permutations. So far we have seen that in the topic combinatorics, just how to define factorial, and on the basis of a counting principle we have solved some problems. Now only we are going to an important topic, permutation. Permutations of distinct objects. That means permutation means permutation means ordering or arranging or listing, ordering, arranging or listing of different objects. Just arrangement of a given distinct objects or ordering of the given distinct objects. Say, for example, 3 things are given to you, or 3 students are, you consider A, B, C, these 3 students, or 3 things, whatever may be, 3 fruits you can take. A for apple, B for banana, C for citrus. These 3 fruits can be arranged in how many ways, or listing in how many ways, or ordering in how many ways. That is the principle of permutation. A, B, C are 3 different things. A, B, C are 3 different things. How many ways, how many permutations are there? How many permutations are there for arranging these 3 things, these 3 different things? How many permutations you can arrange these 3 different things, or these 3 fruits, A for apple, B for banana, C for citrus fruits? These 3 things can be arranged in how many ways? The number of permutations of arranging 3 things. The number of permutations of arranging these 3 different things. How many permutations are there? See, A, B, C. It's an arrangement. And you fix A and you order and interchange C and B. A, C, B. And first B, B, A, C. B, C, A. Then C, A, B. Then C, B, That's all about the arrangements. 1, 2, 3, 4, 5, 6 arrangements are there. The number of permutations of arranging three things in three different ways are how many ways? 6 ways. 6 ways of arranging three things in arranging at a time, taking 3 at a time. So this is defined by the number of permutations of three things is defined by 3p3. It is denoted by 3p3, number of three different things arranging 3 at a time. That is 3p3 is 6 ways, that is 3 into 2 into 1, that is 6 ways. See, 3p3 is 3 into 3 minus 1, 3 minus 2, 3 minus 3. Here we have three things, therefore 3 multiplication. So first you consider 3, remaining next to 2 and last final 1. So 3p3 is 3 into 2 into 1, or otherwise we can define by 3p3 is equal to 3 factorial. So this is our first one idea. Number of arranging three given things, number of permutations of three things, arranging three things is 3p3, that is 6 ways. It is denoted by 3 factorial. And similarly, now 4 things, number of, out of 4 things, how can you arrange the 2 things at a time, taking 2 things, arranging 2 things out of 4 given different things. You will see now, okay? Now, the number of permutations of, out of these 3 things A, B, C, number of permutations of 3 things taken 2 at a time. A number of permutations of 3 things taken 2 at a time. Number of permutations of arranging, number of permutations of arranging 3 things. Number of permutations of 3 things taken 2 at a time, that is 3p2 we have to find. Out of 3 things, we have to taken 2 things at a time, 2 different things. How many ways we can arrange? See, AB, AC, AB, AC, BC. AB, 2 things, BC, 2 things, AC. And these 3 things can be rearranged as BA, CA and CB. Totally 6 ways. Here also, number of permutations of arranging 3 things taken 2 at a time is also 6. It is also, how can you define 3p2 is, this can be expressed as 3 into 2. Here, two numbers should be reduced from 3. 3, first time 3, next step is 2, that's all. 2 things only. So, 3 into 2. 3p2 is 3 into 2 only. If you find what number in the place 3p2, so the 2 number is, you have to reduce 2 numbers only. Similarly, 3p3, you get 3 here. Therefore, 3 numbers you have to reduce from 3. 3 into 2 into 1. That's why you get 6 here. Here also you get 6, but 2 times only you have to, 2 things you have to arrange. See, like that, here 3p3 and 3p2 are the number of arrangements are same, but the arrangement is different. Number of arrangements are same, but the arrangement is different. Okay, here 3 things taken 2 at a time, here 2 things taken at a time. Here 3 things at a time, here the first case we are taking 2 things at a time. So this is another example. 3p2 and 3p3 are value is same, but the arrangements are different. The next case, out of 4 things, A, B, C and D, out of 4 things, how many arrangements are there taking two things at a time. That is 4p2. Number of permutations of 4 things taken 2 at a time. Here 4 into 2, 3 only. Number 2 here, therefore 2 numbers we have to reduce. 4 and again 4 minus 1 is 3. 4 is 3. 12 permutations are there. See, number of 4 things. Out of 4 things, 2 things can be arranged in 12 ways. Okay, we can see AB, AC, AD, AB, AC, AD, BC, AB, AC, AD and BC, BD, BC, BD, AB, AC, AD, BC, BD, BC, BD and CD. AB, AC, AD, BC, BD and 3D. 1, 2, 3, 4, 5, 6. And these 6 things are rearranging once again, taking reverse order. BA, CA, DA, CB and DB and DC. Totally 12 ways. So, number of arrangements of 4 things taken 2 at a time is 4p2, that is 4 into 3 is 12. See, now I am going to give you some examples only. First of all, I am going to derive a general concept through the examples only. We are going to arrive at a general concept. N things taken all at a time. NPR we have to derive. See, for that I am giving these so many examples to you. And okay. See, so far I have defined some different objects. Arrangement of different objects are taking a required number of objects. See, so far we are saying 3p2, 3p3, 4p2 and so on. See, these number of permutations of 3 things taken 2 at a time. This is 3 into 2, you get 6 ways. Number of permutations of 3 things taken 3 at a time, A, B, C, ACD, like that I have defined. Here also you get 3 into 3 numbers are there. There were 3 into 2 into 1, that is 3 factorial, that is equal to 6. 4p2 is 4 into 3 only because 2 numbers are there in the name. At a time, we are out of 4 things, we are taking 2 times, therefore 2 things only, we have to multiply 2 only. 2 numbers only, that is 12 ways. See, every permutation, the upper number should be greater than the lower number. Because out of 4 things only, you can take 2 things. The upper number should be greater than the lower number. Given things are 4, out of 4 things, you can select 2 things. But 2p4 is not possible. 2 things given, from that 2 things, we cannot choose 4 things. 4 பேர்ல 2 பேர் வாங்க சொல்லலாம், 2 பேர்ல 4 பேர் வாங்கன்னு சொல்ல முடியாது. See, 4 people are there. From those 4 students, I can select 2 students. But the number of students is 2 only. How can I select 4 students? So, the upper number should always be greater than the lower number. This is possible. This is not possible. You will consider these things in your mind, and I will going to derive NPR, the value of number of permutations of n things taken all at a time, in our next video. Okay, we will see the general formula in the next video. Thank you.